everyone, to today's decarbonization lunch. We're going to be focusing on decarbonizing commercial buildings and in particular the rooftop units that provide them with heat and ventilation. We're going to give folks a couple of minutes to trickle in, or maybe, well, give them 60 seconds to trickle in, and then we'll get started in earnest.
Oh, because he was a ball maker.
All right, welcome everyone to today's decarbonization lunch. I think we've got enough folks in the room virtually to start up. My name is Omar Bimji. I'm the Sustainability Services Manager for SES Consulting, and we've been asked by ZEBEX to help out with some of the decarb lunches, including today's session. We are going to be looking at decarbonizing rooftop units. This session is going to cover best practices, common barriers for HVAC systems broadly, but again, we're going to be really focusing on rooftop units, those little workhorse animals on so many of our commercial buildings. In more depth, we're going to be sharing learnings from the City of Vancouver's recent on-site barriers to commercial building electrification study, highlighting some of the obstacles, but also the practical solutions that it uncovered for decarbonizing HVAC systems. We're also going to hear about a case study with a bit of a sneak peek into the fuel switching work that VanCity Credit Union has been doing with their pilot HVAC retrofit. And we'll also towards the end talk about where dual fuel options fit in, where they make sense, and some best practices and lessons learned on maximizing the decarbonization potential of these systems. We're using Zoom today for today's meeting. Hopefully everybody's familiar with it, especially after the last 5 years of more of these kind of virtual sessions. Going to ask that everyone save their questions and comments to the end, but really encourage you to use the chat to add those questions in so that we can keep track of them and make sure that they're addressed when we get to the discussion period. And to answer back. There's a great community here that usually joins and a lot of wisdom in the room. So if you see something that you want to add to, that you want to respond to, please do feel free to engage in the chat. The session is going to be recorded, so ask that you keep your videos off if you'd rather remain anonymous, and your microphones off so that we can get the most out of the speakers and what they're going to be providing. And there'll be, as I mentioned, a discussion and Q&A period at the end so that we can dig into anything that's opened up during the presentation or anything that we sort of get inspired to talk about then. We've got 3 speakers today lined up for you. Ashley St. Clair from the City of Vancouver. She's a senior green building planner there. We've got Nicole Montgomery, who is the Sustainable Operations Manager for VanCity Credit Union. She'll be talking about the credit union's work on this file. And my colleague, Stephanie Poole, who is a principal with SES Consulting, and she's going to be digging into the dual fuel side of this operation. So with that, I'll turn it over to, oops, wrong person. Yeah, no, there we go. Ashley from the City of Vancouver. Just as a little bit of an intro, Ashley's been involved in sustainability and energy in that sector in British Columbia for over 10 years. She's currently a senior green building planner with the sustainability group at the City of Vancouver, and her main focus is developing equitable carbon reduction policies for the commercial building sector. So that's a lot, but Ashley's here to share her expertise on this file, and I will pass it over to her.
Okay, amazing. Thank you, Omar, and thanks everyone for joining us on this very rainy Friday. So yeah, I'm with the City of Vancouver. I wanted to share a bit about the work we've been doing to understand the opportunity around decarbonizing rooftop units. RTUs aren't typically the star of the show. As Omar mentioned, there's sort of these simple workhorse units that tend to kick around for extended periods of time. Some of these old units running their lifespan up to 25 years. And when we're looking at efficiency and decarbonization opportunities, I do think it's an exciting space. So I'll talk a little bit about why I think that is. Next slide, please. So in Vancouver, we've got some ambitious climate targets. We're aiming for net zero by 2050. This is a pretty standard slide that we've got in many of our presentations. So the majority of our emissions come from buildings. It's probably not a surprise to many people in the room here. So 57% of our emissions are coming from buildings. And when we're looking at reducing those emissions, commercial buildings are an essential part of the picture. They're about a third of that emissions pie, if you will. Next slide. Thanks. So in the existing buildings retrofit space, one of the challenges that I've been faced with is sort of where do we focus our efforts first? Every building is so different, and that's what makes retrofits so much more complex. You're dealing with, a building's age, construction type, do they have enough electrical capacity? What are the pieces of HVAC equipment? Were there past renovations? Like any number of things in the building's history and makeup are all kind of coming together to shape what is possible in a retrofit solution. So scaling solutions in this space, it's not like new construction where you've got this blank slate. Really, every project's got its own unique set of constraints. So when we're looking across building types or equipment types, this is the framework that we've been using to kind of talk about and understand where are the opportunities that are the most ripe. So we've got this kind of 3-lens approach. What is the carbon impact? What are the technical barriers, and how ready is the industry for any particular retrofit solution that we're looking at, or retrofit space? So this has been really useful for me in terms of identifying like where can we move quickly in terms of decarbonization, and where we might need to do a bit more work in terms of market transformation. So spoiler alert, rooftop units from this framework are kind of emerging as an opportunity that really stood out in terms of being practical and near-term achievable. Next slide, please. So I'm going to walk through rather briefly these kind of three lenses of the framework. So we'll start with carbon reduction impact of RTU electrification. Next slide. So to understand the scale of the opportunity, we looked at, want to get an understanding of how many RTUs are in the city, where are they, what types of buildings do they serve, how big are they? And what we found when we started looking was, there's about, there's over 7,000 units. This is, we're estimating over 7,000 units on over 2,500 buildings, serving roughly 64 million square feet of space in the city of Vancouver. Most of the units are smaller, 3, 5, 10 tons. So you can see in the pie chart, over half the units that are out there on the existing building stock are less than 5 tons. And the majority of those are found on our smaller commercial building stock, so under 50,000 square feet. Next slide. When we think about what does that amount to in terms of emissions, we're estimating a potential of about 33,000 tons of emissions of CO2 per year is the carbon reduction opportunity. So this, in relative terms within the commercial building space, this actually, it's quite a large opportunity. Kind of following closely behind the opportunity in the largest commercial buildings, the largest office segment where we've got our building performance regulation. So it is a big opportunity in terms of greenhouse gas emissions reduction. Next slide. Okay, we'll move into technical barriers and how complex are these projects to undertake, and what are the actual barriers. So I'm I'm pulling a lot of this from the work that we did with SES Consulting recently on, Omar mentioned this on-site barriers to commercial building electrification, where we looked at 18 commercial buildings across offices, retail, assembly, hotels, and light industrial. What we wanted to do was really capture the array of typical HVAC setups that you would find and cover all of the classic pieces of equipment that you're going to find in the commercial building stock in the Lower Mainland. We wanted to understand what are the barriers faced when electrifying these buildings, sort of the on-the-ground barriers, both at the equipment level and then at the building level if you're trying to electrify all of the equipment in the building. Some of the on-site barriers we looked at were, structural requirements, space constraints, these very practical things like a lot of buildings don't have space on their roof for a heat pump, or their roof needs to be structurally reinforced. And these aren't things that are typically captured in kind of the broader cost and emissions modeling. We also looked at operational complexity. We did look at cost and we looked at market readiness. It is quite a comprehensive study, but I'm going to reference specifically the findings for rooftop units that came out of the work. Next slide, please. So we're zooming out to like a very bird's eye view here in terms of study results. So when we look at how common each type of equipment is in the general building stock and compare it to, the feasibility that we found in the work that we did, rooftop units very much came out near the top. They're ubiquitous, they're everywhere, there are a lot of them, and they are quite easy in terms of, particularly relative to other pieces of equipment. So from a scalability perspective, RTUs are very well positioned. Next slide, please. On the technical side, these are kind of some of the key findings from an electrical perspective. Most RTUs we found that we looked at could be swapped with heat pump units, either all electric or dual fuel, without an electrical service upgrade, which can often be a significant barrier when you're trying to retrofit. So typically, existing rooftop units already have direct expansion cooling. So the new unit's actually adding minimal electrical load. And this is particularly true if you're talking about a dual fuel unit. So we found very, very low barrier in terms of electrical capacity constraints when it came to the retrofits we looked at. And first, on the structural side of things, we found that heat pump RTUs are very much similar in size to gas-fired units. And especially when we're talking about units under 10 tons, the heat pump units were slightly heavier, but not in a meaningful way that where structurally, you would need any significant reinforcement that would add a significant cost. When you get into the larger packaged units, the 15, 20 ton and 30 ton units, the weight differential we saw could grow. But for the vast majority of the smaller systems, there was minimal structural impact. And for cost, really, of all the equipment that we studied, RTU had the lowest cost premium relative to like-for-like gas replacement. And they really came out as one of the most cost-effective emissions reduction options of all the equipment that we looked at in this study. Next slide. So finally, we'll talk about industry readiness. Next slide. So on the market side, product availability, what we found was, heat pumps have been on the market for some time, for some years now, 5-7 years, and they're widely available from all of the major manufacturers, especially in the smaller sizes. Introba had done some analysis a few years back on RTU technology availability in the local market, and they found that locally, there were over 15 products available in the less than 5-ton range from all the main manufacturers and suppliers. So the technology is there. It's here. It's proven. But one of the challenges I think that we've been hearing the most is, and I think could be changing to some degree, is on lead time. So the lead time on these on the heat pump units tends to be longer than just getting a like-for-like replacement. And I think that can be a significant barrier in many cases, especially if you're if there's a replacement at time of failure where time is of the essence. But like I said, I do think that's changing. We've been hearing more and more that local suppliers in the Lower Mainland are now starting to stock more heat pump RTUs, and lead times are dropping. So that's good news. I think it's really going to be a function of, as demand grows, suppliers will start stocking. In terms of awareness and adoption, it seems as though awareness and adoption are improving. But if we are talking about scaling, I would also say that contractors are still defaulting to gas units for replacements. We're still in that sort of earlier stage of adoption. I think a lot of it that comes down to cost competition, and familiarity. So gas units are still cheaper upfront, and they're what contractors know best. So Fortis has their dual fuel rooftop unit incentives, which are quite lucrative. And I think that's going to help shift the dynamic and encourage more uptake. But it's still an area that, in my opinion, we need some targeted support to really move towards market transformation. Standardization and performance. I don't want to say too much on this because I think Stephanie is going to go into some of the weeds here. I just want to flag that there's, from what we've seen, there's more room for consistency in terms of how these systems are commissioned, and how they're operated. And I think, yeah, we can see some enhancements in this space to really ensure that that installed units are delivering on the modeled efficiency and emissions outcomes that they were put in to achieve. And on permitting, just to flag the role that cities, that municipalities play here, permitting is really one of the core areas where cities have direct control. And in Vancouver, we do have a dedicated mechanical permit for heat pump installation, and we've had really good feedback so far on turnaround times on facilitating those quick permits, which I think is really great. And we've got guidance documentation out there on siting, on when you're looking at your rooftop unit, your heat pump unit placement, what might trigger other processes and for review at the city, and how you might want to avoid that. It's a small thing, but it can make a big difference in terms of making a retrofit go smoothly. Next slide, please. Okay, yeah, so this is it. That's my last slide. I think that's where we're at. The technology's here. It's proven. The technical barriers are low when we're talking about rooftop unit replacements. And I think now it really comes down to coordination and momentum. We need to make it easy. We need to normalize it, make it the norm for building owners and contractors to choose that high efficiency option. And that really means increasing awareness, sharing real world projects and lessons learned like we're doing here, streamlining permitting, and having those clear signals from government and from utilities in terms of regulations and supports. So yeah, I will leave it there. And thank you all for your time. I'm excited for discussion to come. And with that, I'll hand it back to Omar.
Thanks, Ashley. You kind of stole my transition there, because yeah, the next step is learning about these things, making them more successful in terms of their installation, getting more people familiar with them, and just making them more real and viable out there in the market. So with that, I'm going to hand it over to Nicole Montgomery from VanCity to talk about her work on HVAC retrofits and what that can teach us about this little unit and how to decarbonize them. By way of introduction, Nicole is a sustainability specialist who spent her career working in the sustainable building design and infrastructure area, economic development, sustainability reporting, and a lot of other facets of the field. In her current position, Nicole is the VanCity Credit Union Sustainable Operations Manager, and she's charged with building the organization's operational net zero and carbon offset and removal strategies at both a high level and when it comes to getting into the weeds and figuring out how that's going to happen. So I'll turn it over to Nicole, and we'll learn about her work on this portfolio.
Thanks so much, Omar. So I'll just jump right to it. I'm seeing some questions in the chat, and hopefully some of what I'll talk about will answer that. So VanCity has had a long history of leading in sustainability. In 2014, SES actually helped us design a heat recovery system that reduced the GHG emissions from our head office by 75%. Since then, the climate emergency has shifted the focus from energy efficiency to drastic emissions reductions. So in 2021, VanCity set a goal to achieve net zero in its financed emissions, meaning reducing the emissions from its loan portfolio to net zero by 2040. And as a community-based credit union, most of our emissions come from commercial and retail mortgages. So that's what we're trying to reduce. But that's not what I'm here to talk about. When I joined the organization in 2022, my goal was already defined. It was to achieve net zero in our operations. So with that in mind, but we didn't really have a plan to get there yet, we started by solidifying our data, then testing some tactics to get to our goal. We started with monthly monitoring of utility consumption, identifying outliers and variances. Whenever there was a spike in relative energy consumption, this prompted an investigation, which usually ended up in controls optimization. So if you've ever been around the Lower Mainland, you might have noticed that our branches are scattered all over, and they're usually strip malls in suburbia, which, you guessed it, they have rooftop units. So if you go to the next slide, controls optimization yielded really great results for us. Here's an example from one of our branches. This one had 4 rooftop units. Three of them were heat pumps with gas backup, and one of them was a rooftop unit that was gas fired. So all of them haven't reached end of life yet, but this branch had DDC, so we were able to get our controls contractor to clean up the code, and look at that. We went from, I actually don't know how many tons, it's probably 4 times that, so maybe 16 tons in this branch to 4 tons in 2024. So next slide, I'll caveat what I'm about to say first. ASHRAE level 2 studies are great and make sense for folks who are new to doing this work and own their own buildings and are willing to do significant renovations. But we tried doing a couple level 2 studies in our branches, and it didn't end up being the best fit for our goals for a couple of reasons. First is we lease most of our spaces, so envelope measures don't really make sense for us. Energy conservation is obviously really important, but our goal was to become less reliant on fossil fuels. So what we really wanted to know, and it took a while to define this question, the question was, how many fully electric heat pumps can our branches handle without having to necessitate an electrical upgrade? So in this process of trial and error, what we really wanted to do was go straight to design. And in this webinar, we're actually joined by our dream team of designers and contractors. So I just wanted to give a shout out to Kenny and Richard from Impact Engineering, Ron from Ainsworth, and Calvin from Bemister, who have been amazing in sharing their deep knowledge with us and being on this learning journey. So next slide, sometimes framing this change as modernization resonates more clearly to folks who don't work in this space or need a little convincing. So we're responding to the climate crisis with new technologies. So along with replacing our RTUs, we wanted to do it in a way that would also modernize and improve our building management systems. So we require DDC be installed at every new location that has a heat pump so that we can investigate and diagnose issues remotely. So we built this framework that looks almost exactly like the city one. We love our Venn diagrams, to roll out our portfolio decarbonization. So we got an understanding of the goals of each stakeholder. So that would be the climate team and our real estate management team, and working in a space where these goals would overlap. So Omar, if you wouldn't mind like clicking through that, because there's a bunch of goals for like the different circles, and then we just wanted to work in that middle space there. So we've installed 12 rooftop units across 4 branches in the past year and a half. We have so many locations that we can prioritize these replacements in so many ways. Like we can rank them by GHG emissions, energy use intensity, and lease expiry. and so on. But what ended up working for us was ultimately by prioritizing them by equipment rather than location, and then by end of life date. So we have our short list of locations with rooftop units that are at end of life. And then I start off with consulting our real estate team on a couple things. Are we, VanCity, responsible for the replacement, or is the landlord responsible for replacing that? And typically it's about, like, from what I've heard, about 2/3 of the time, the renter is actually responsible for replacing the equipment, and then about 1/3 of the time it's the landlord. So that was key. Next is, do we have enough lease runway to justify the investment? So if it's a go, I leave the negotiations in the hand of our very capable real estate team. They're much better than I am. And then I provide whatever information on the equipment and electrical capacity they need. So we work with our with Calvin from Bemister, and then Impact and Ainsworth to come up with, like, the best combo of which equipment, like reducing, like making sure that we have enough electrical capacity and whatever additional electrical design needs to happen on the roof before we do the installation. Next slide, please. So our first fuel switching project was in our Guildford branch in Surrey. I think you might have to click through a few times, Omar, sorry, that slide's a little weird. So our first fuel switching branch was in our Guildford branch in Surrey. There's more info on that in the B2E case study, which I've pasted in the chat. We installed 5 fully electric heat pumps in March 2024. So we now have a full year's worth of data showing that our electrified energy consumption is lower than the previous combined energy consumption in EKWH. So there was a minor increase in annual utility costs, which you'll see in the other graph there. Next slide, please. Next is, we have another branch where there are 3 rooftop units, but only 1 reached end of life. So we just replaced that one, and you'll see some significant reductions already with just the 1 rooftop unit. So we're constantly learning, and the big thing we learned with this installation was to check for air volume. So we've been including a quick check with our air balancer and engineer to make sure that there's the right amount of air supply for each of these spaces. Without getting too detailed, like, sometimes these can change over time. So what was okay with building code before might not be okay now. Next slide. And for this branch, we replaced 3 out of the 6 gas RTUs, only because only 3 have reached end of life, and we'll do the other 3 later. There's a bit more gas consumption than we'd like here. So right now we're working on that. We're working with our controls programmer to fix that. And that's it. I'm really happy to and willing to share more information on this. So feel free to reach out to me if we don't get to answer your questions during this webinar.
Thanks, Nicole. Yeah, I think I mentioned this in our pre-meeting. I loved your define your problem slide, because it's as energy consultants, selfishly exactly what we want to see with clients coming to us or tackling these kind of issues, knowing exactly what they want and what's viable for them and realistic, so that we can focus in on helping them get what they are looking for and moving forward, rather than worst case scenario designing a shelf ready study that just kind of doesn't really speak to anyone. So it was great. Thanks for sharing that experience. And we're going to be tipping over to my colleague, Stephanie, to clean up and take us home. Stephanie is a professional engineer. She's got extensive experience with energy efficiency, decarbonization, through audits, implementation, commissioning, project management, planning, you name it. Stephanie is actually a former teacher, and so she does an amazing job of taking all this high-level technical stuff, project management, et cetera, and turning it into accessible information for lay audiences. She regularly applies her expertise to develop projects, but also courses for a range of organizations, CIT, BC Hydro, Fortis BC. She's also an editor at automatedbuildings.com, and she is part of the Building Decarbonization Alliance's expert advisory panel, remotely, of course, because they're over in Ottawa, but she's regularly tapped by that organization to help them understand some of the challenges she'll be talking about today. And with that, Stephanie, I will turn it over to you.
Thanks, Omar. Comprehensive introduction. Amazing. Well, I'm going to talk a little bit about dual fuel specifically, because as Nicole mentioned, there are scenarios where she can fully electrify, and that's amazing. But there are also a lot of scenarios where that's not feasible. And so I want to talk about the alternative and how to maximize emission reductions when you do pursue that alternative because you have other constraints. And the reason I want to talk about this is because dual fuel RTUs actually have quite a lot of potential, but what we're seeing in the industry is they're not actually living up to that potential. So that's why I want to talk about this. So yeah, I already said it. So let's go to the next slide. Amazing. I will touch on this really briefly because there's a full electrification guide that outlines all of this, but it is worth noting that just switching from gas to electrification is likely going to make it so that you can't fully electrify because you hit either electrical capacity constraints or, structural upgrade requirements because you're sizing really big rooftop units because you haven't reduced the load first. So there is a phased approach you do want to take to decarbonization and things you want to consider if the goal is to go full electric, or even if it's not, things you want to consider so that you're ensuring your equipment is sized appropriately, not oversized, or reducing the load first, that kind of thing. It is really important to estimate the spare electrical capacity kind of like really early on in your studies. I've seen a couple studies lately that we've actually gone back with clients to redo because they've recommended a bunch of measures, but nowhere in those measures have they considered the electrical capacity. And so it turns out that many of these measures aren't feasible because, the electrical service upgrade would be $500,000. So I think that's one of those things Nicole was speaking to is knowing what you need as far as a study is really helpful in ensuring that you're getting something that's going to be useful. So if you are looking at electrification, making sure that you're looking at the electrical capacity first, and then identifying opportunities that won't exceed that capacity. There are many scenarios where if the option is we need an electrical service upgrade, that project isn't going forward now. And unfortunately, that's the case because of constraints with budget, or even there are some places where it's like, we want to upgrade our electrical capacity, but the service to there isn't sufficient, or the neighboring houses are using too much. And so we actually don't have what we thought we did. So there are constraints there that can make a project no go. And so that's where it's like, okay, well, we can't do a full electric RTU. Maybe we want to do a dual fuel because it actually will fit in there. But one thing you do want to consider is, using real-time metering. I feel like every time I do a presentation, I say that, metering our actual load, but it is consistent within the industry, regardless of the RTUs versus domestic hot water versus boiler versus, any system is going to be oversized if you're using standard rules of thumb. So using real-time metering, maybe we'll just skip to the next slide and then I'll just mention that there's more information available, but some of the principles to effective decarbonization, this is just a really quick snapshot. It's actually from the electrification guide. I'm assuming that someone will put that in the chat as part of this. So Omar will do that for you. Thanks, Omar. This is from the BC Building Electrification Guide. And so each of these are outlined in great detail on how you go about this, but I'm sure as many of you have come to realize that if you're trying to electrify, or even if you're trying to get 50%, 40%, get some of the way there, you don't want to skip right to electrification, right? We want to look at load reduction. We want to look at heat recovery. We want to investigate envelope upgrades if that makes sense. It may not, especially, in Vancouver where the climate is mild, but we want to look at those before we skip to sizing our equipment. And that's all I'll say about kind of efficient electrification, just because there's lots of other information available. But I do want to flag what I'm going to talk about here is, let's say you did all of this, you did it all correctly, you did it in the right order, and you still don't have enough electrical capacity. You can't do an electrical service upgrade. What do you do? Well, chances are you might want to go with a dual fuel unit because you can actually save quite a lot of emissions, assuming, and this is the caveat, assuming it's commissioned and performing as intended. That's what we're going to talk about here. Next slide. Thanks. Really quickly, because this is not well understood. I just want to highlight the difference between an RTU, an MUA, and an air handling unit, HU, because what we're talking about here is mostly RTUs, but I will touch on MUAs. So an RTU, rooftop unit, is what you'll typically see on a roof. Now, to be fair, they could also be on the ground. It would could be a packaged rooftop unit, but the difference with a rooftop unit is that it's mixed air, which means it takes return air from the space and outdoor air from outside, mixes it together, heats it and cools it, and sends it into the space. So you'll see these office buildings will have these. Yeah, you'll see them around a lot. And so that's what we were studying as part of this barriers to decarbonization with City of Vancouver. Makeup air unit, you'll see these in commercial kitchens, you'll see them in multi-unit residential spaces to serve the corridors. It is 100% outdoor air, which means it takes purely outdoor air, heats it and or cools it, and sends it into the space. Now you can imagine a makeup air would require a lot more heating and cooling because it's taking 100% outdoor air. So if it's -5 degrees out, it's 100% -5 degree air. Whereas a rooftop unit is going to take, 10% -5 degree air and mix it with 90% of 20 degree air. So it needs a lot less heating and cooling. And that's a really important caveat. So a rooftop unit, yes, makeup air can also be called a dedicated outdoor air system. Thanks, Roberto. So it's really important to know the difference because a rooftop unit, because it is mixing the air, it is going to be easier to electrify. It typically needs a lot less heating and cooling than a makeup air unit. And so that's a really important difference. And then an air handling unit, those are those big ones that sometimes you can walk inside. They're built kind of in a mechanical unit or in a mechanical room, and they'll have, they could have hydronic heating, or they could have a heat pump, or they can have DX, or they can be very customizable. You'll see these in bigger buildings, like shopping malls, big office buildings, municipal facilities, those kinds of things. So I just want to highlight the difference because I'm going to talk today about rooftop unit and makeup air unit. But the best opportunity and what was outlined in the study with City of Vancouver's is rooftop units specifically because they're mixed air. Next slide. Okay, so I kind of explained this. And the one other thing to note that Ashley flagged early on is that many rooftop units, not all, but a good number of them will already have cooling in place. So they'll have gas heating and they'll have direct expansion cooling, which means that if you want to add a heat pump, you've already got electrical running up to that space. You've likely already got sufficient capacity because the heat pump's really not going to be that much bigger than the air conditioning piece. And that's why it's so easy to electrify these. Next slide. So the opportunity here is I can't go full electrification. I've tried it. I don't have electrical capacity. So I'm going to go with an air source heat pump with gas backup. And typically you can do these with no electrical service upgrade. Almost always you could do it with no service upgrade if they already have cooling. If they don't already have cooling, it's a bit more of a maybe, but still possible depending on the building. Because you already have many of the same components in the new versus old system, chances are you don't need much structural upgrade. You might need, a new pad. There may be some considerations if the newer unit is slightly bigger or different shape, you might need to consider that, but it's typical that you wouldn't need a big structural upgrade. So the costs associated with the change are relatively minor. And here's the important thing is that the predicted savings of a dual fuel rooftop unit can be 80 to 90%. I'd say maybe 70 to 90, depending on where you're operating it. But that's predicted. And the reason I want to talk about it is because we're not seeing that. We're almost never seeing that in practice because these are not really commissioned properly. Because people put them on, assume they're a standard gas-fired unit and that it's they're installed, walk away, done. But low carbon equipment, even rooftop units, which are arguably one of the simpler ones as given all the possible low carbon equipment available in the industry, even these ones need more commissioning than their like-for-like replacement siblings. So they need to be considered. And so you can achieve quite a lot of your savings, but only if you spend the time to commission and size and get this working the way it should be. So FortisBC does have a rebate. It's meant to cover about 30% to 50% of the total project cost, which is meant to cover almost 100% of that incremental cost. So the incremental cost being the like-for-like replacement is this much, and what we see in practice is the heat pump version is about 20% more expensive. And so that Fortis incentive is meant to cover that totally, to incent you to get the heat pump version rather than a like-for-like replacement. Next slide. So makeup air units, I talked about this. You don't see cooling as much in makeup air units. Now, many makeup air units serve a kitchen. In that case, you'll often see cooling. So that's something to consider, is that, you know, if you're trying to quantify where are my best opportunities, where can I take a rooftop unit or a makeup air unit and put in a dual fuel system? These are going to be, ones with cooling are going to be the easiest, right? Because you already have the electrical in there and chances are you won't need much upgrade. Next slide. Perfect. So again, the opportunity here is a makeup air heat pump with gas backup. The caveat here is that a makeup air unit heat pump is going to need to be like the actual heat pump size, and even the gas backup size is going to be quite a bit bigger than with a rooftop unit because it has to heat that really, really cold air. It can't mix it with the return air first. So it's much bigger, which means that often you will need structural reinforcements, which is why makeup air units are slightly harder to electrify here. Now, obviously, if you already had cooling in place, maybe you don't need that upgrade. So it is dependent, but makeup air units are going to be like a little bit trickier than rooftop units to electrify. So they are going to save, you know, between 30 and 50% gas reduction. Again, because they are using 100% outdoor air, they can't operate down quite as low temperatures. And so they're not going to see as much savings as that rooftop unit, which can mix the air. And so it can go down much, much colder. There are Fortis rebates available for this. They won't cover the full incremental cost between like for like and a makeup air unit heat pump. They'll cover about 50% of the cost depending on how many other upgrades were required. Next slide. Okay, wonderful. Thanks. So as I said, the reason that we're focusing on these dual fuel rooftop units is because they have a lot of potential. You know, you can see up to 30 to 90% savings of your gas, depending on how well it's performing. But what we're seeing is that they're not performing. People are putting these in and they're seeing, well, I'll just give you an example here. This was one case study. It's actually written about in the electrification guide in more detail. This was a social housing building, so it is makeup air, not rooftop unit, but the commissioning and considerations associated with a makeup air unit and a rooftop unit are going to be very, very similar. So I'm talking about this case study just because it's got some good data right now. Next time we talk about this, I'll have a bunch more rooftop unit ones, but these are going to be like the learnings are going to transfer, which is why it's important to talk about it. So these buildings, again, were modeled to save, let's say, 50% of the gas. But in practice, what was happening is we're seeing a 10% savings in one and actually an 11% increase in gas in the other building. And this is, you might look at this and be like, wow, they really messed that up. That's really unfortunate. But this is like the norm that we're seeing, is that these are not performing as well as they are predicted to perform because the commissioning is not really being considered or not being done at all. And so that's why I really want to highlight this, is because rooftop units have this potential, but we're not seeing it in practice. So you can go to the next slide. So what we were seeing in this specific example is that the heat pump was actually not being used as the first stage of heating, or it was cycling on and off inappropriately. And so it has to do with the set points. The way that these are typically controlled is it's like, okay, I'm going to use my heat pump down to say -5 degrees. And then after I'm going to use my gas. Now, this is a makeup air unit, so you wouldn't actually use it down to -5, but that's the switchover temperature that Fortis dictates for this climate zone. So that's why I was using it as an example. But those set points are important to tweak and to look at, like, how is that switching over? Because we were seeing that the heat pump was cycling, the compressor was cycling, and the gas was cycling, and the gas burner was short cycling. This has to do with where the duct sensor was placed. It was actually too close to the heating. So the heating would turn on, the sensor would be like, oh, I'm 40 degrees, I'm way above set point, turn off. And then the cooling would come on, and it's just kind of like it was a mess. And so it wasn't saving very much energy. And so it's really important to look at those and to tweak it. And on the next slide, I'll talk about how you can do that. There were some other things with the install that weren't proper. There was vibration. They should have had a vibration pad on there, an isolation pad that should have been done as part of construction. It wasn't, so the occupants were hearing this vibration. It was being very disruptful. They were not feeling very good about this retrofit. And then there was some condensate pooling. That's what that picture is. Again, the condensate drain is one of the things we see very often in all heat pump installs, is like the condensate is a big issue. And if it's not installed correctly, you can get freezing or pooling, or it can make a mess. So in this case, we are currently recommissioning all the set points. We actually installed data logging on these heat pumps, and I'll talk about that because Nicole had mentioned that for all her retrofits, they install a building automation system. And that's like, you know, what they want to do so that they can monitor the heat pump and the rooftop units. Amazing, so great. For many of the clients we work with, that's not a feasible retrofit to add a building automation system. So what you can do, and many of the newer rooftop units or makeup air units have these, is you can install data logging capabilities. So it basically trends certain points, and then you can access it. Some of them that are older, you need to like go physically put a USB in and out, but the newer ones have apps. And so you can actually monitor some of those points via an app without a building automation system. And so that way you can say, oh, hey, our compressor is cycling. Oh, wow, our heat pump isn't being used right now. It's only the gas. Okay, our set points are off. So it allows you to kind of troubleshoot it in a very similar way as you would with a building automation system, but without having to do a full building automation system upgrade. And then, of course, we just, you know, fixed the contractor, the drain pan, isolation pad, did some of those basic things. Next slide. Thank you. So in general, what we typically see to maximize emissions reduction is commissioning and some sort of verification, whether it's data logging, whether it's on the BAS, some sort of way to watch the performance of this rooftop unit and actually make sure, like, oh, okay, the compressor is coming on when it's supposed to. Because what we see in practice is that commissioning is a very loose term right now. And there's a difference between performance commissioning and functional checks. Functional checks are like, yes, the compressor can turn on, check. Performance commissioning is, yes, the compressor turns on at the temperature it's supposed to, it performs properly, it's not cycling, it's turning off when it needs to, like that's performance. And so that's not always being done in the industry right now. So it's really important to make sure in your performance specifications or in your RFP or your request for quote that you're specifying, okay, I want performance commissioning to be done. And you can put in like a specific list of, I need you to check it at this temperature, I need you to perform these tests. You can make it very detailed, or many of the contractors we work with have documents that they use, and you can ask them for theirs and you can just validate that it works for you. I would also recommend that you have some sort of way to visualize that data, whether it's data logging or whether it's connecting to the BAS. I just wrote a performance spec for 4 rooftop unit replacements with a commercial client, and in the performance spec, we required the rooftop unit be BACnet IP, that it had data logging, that it had, you know, demand control ventilation, modulation, some of those like a variable speed drive, some of those things that will ensure maximized emission reductions. So we're validating it. And then the other just key learning I'll say here is for a dual fuel makeup air unit, because remember, it can't run down quite as low because it's 100% outdoor air unit. What you can do if the goal is to maximize emission reductions is you can put an electric preheat coil before the heat pump. Because what happens is around 7 degrees, the evaporator coil starts to freeze when the air outside is less than 7 degrees. And so that means that you can only run your makeup air unit heat pump to about 7, which is quite a bit higher than a rooftop unit would run to, which is say -5, -10. So if you put an electric preheat coil in there, now all of a sudden you can run it down to maybe -3, which increases the range you can run the heat pump quite a lot and is going to get you more emission reduction overall. Yeah, those are some of the big ones. I talked about right sizing. You can read all about that in the electrification guide if you wish. And then this is just a little flag that if you're going to do a replacement of a rooftop unit from like for like to some low carbon equipment, there should be steps along the way where you engage with the operator, the owner, the contractor. It's not just I put it in and then I'm like, okay, operator, go ahead. They need more support. And so this was a flag that we've kind of worked with the city of Vancouver to identify what the steps along the process might look like to engage people so that they can operate their equipment. And I will stop now because I am at my max time. And I see lots of questions in the chat.
All right, thanks, Stephanie. Yeah, I think I gave you a do not pass of 1250 and you nailed it, which I shouldn't be surprised by. Yeah, that's the 3 presentations we have. We got 10 minutes-ish left for questions, discussion. I'm going to stop sharing my screen, and that will pull up the view everyone, even though we've got 100 folks here. So if you don't want to be in the recording, please make sure you turn off your video. But yeah, I'll get a chance to actually see the chat and what has come up as discussion items and questions for our panelists. You all look great. Thanks, Mariko. I have a few questions, but I'm going to cycle through this unless anybody, any of our presenters noticed that there was a specific question that sort of followed on that they really want to make sure they get a chance to key in on that was raised in the chat. Anything jump to mind for you folks?
Actually noticed that Scott's been going through and responding to the questions in the chat. So amazing.
Yeah, I wanted to flag that as well. Thank you, Scott. Scott worked closely with me on the City of Vancouver study. So thank you for diving into those technical questions. Appreciate it.
Yeah, no problem. And one question that sort of there was a theme in the questions was around costs and cost premiums. And certainly this is one of the big questions of electrification in general is there a cost premium and how much of a cost premium is it? And so we really unpacked that in that study, and you know, there is a cost premium, but it's for rooftop units, it wasn't that significant, and as Nicole mentioned, that in some cases it was the same price. Like you depending on which equipment you get and what particular size and product you're looking at, it might be a lot of money, might be not very much. Nicole, did you have more comment on that?
Yeah, I think like it depends on a lot of things. Obviously, like it depends on the model. One thing I didn't mention, but it's in our case study, is that we're trying to future-proof all of this too. So our new installations use the new refrigerant R454B. So that might impact the price a little bit. But I did get one quote because, you know, for some of the ones where the landlord is responsible, we try to negotiate with them and say, hey, if you're responsible, would you mind paying the equivalent in like a gas unit, and then we'll pay for the cost premium. And I think for one of those examples, it was actually like cheaper to go for the heat pump. So yeah, just interesting to get those prices. So I would just recommend reaching out to like a supplier, just to make sure that you have the most recent pricing, because I think they just change a lot.
I might just flag one other thing because I've noticed a couple questions and notes about operator training. So right now there's a couple ways to access operator training. Fortis is incenting operator training right now, so you can access it through there. BCNPHA is developing operator training guides through their nonprofit Resilient Retrofit and RRG grant. SES is developing them, so they're doing, you know, split heat pumps, through wall heat pumps, dual fuel rooftop units, 100% electric rooftop units. There'll be domestic hot water systems. They will be accessible to the general public. They will be hosted on the BCNPHA website. So take a look for those when they come out as well. I think they'll be presented at the upcoming BCNPHA conference in November.
Thanks, Steph. A couple of other questions that I see no one's had a chance to chime in on. David Elfstrom noting that hybrid and heat pump RTUs seem to be like lagging behind air source heat pumps in terms of cold weather performance. A, Scott, Stephanie, would you guys agree with that sense? And B, any sense of like when that gap might close or what would be needed?
I'll just say that I somewhat agree. The rooftop units are a very different kind of piece of equipment because they're mixing air, as Stephanie said. So the need for cold climate equipment is different. But yes, I haven't seen a lot of rooftop units that are designed for cold climate heat pump applications. I don't know, Nicole, have you encountered that in any of your sites?
Sorry, could you repeat the question? I was trying to read.
Have you come across any rooftop units that are rated for cold climate? Like if you're working in Prince George or the interior.
Right. So we don't have any branches in Prince George,
Okay.
unfortunately, but you know, like the valley can have a pretty different weather system than like the rest of like urban areas. So when we do run into trouble, it's usually with the older heat pump models. So there's that. But then also because like the valley, like there's just wind, there's just a bunch of other stuff going on there. So I would actually kind of consider it closer to that. Like the ratings are like about the same. So what we've done to kind of circumvent that risk is to make sure that there's fully redundant backup heat. So that does make it a bit challenging in terms of electrical capacity, right? Because I'll have this big spike in the coldest couple weeks of the year, but the rest of the year it's not really needed. But you know, our priority is also to keep our staff and members comfortable and not have our facilities team drive like 80 kilometers to get to mission. So that's just something that we want to avoid and make sure we're keeping our portfolio operating pretty tightly.
Yeah, that makes sense. Another maybe technical question, although Nicole, with the sort of pieces you put in place, you might have some thoughts on this as well. Fault FDD, fault detection and diagnostic systems, I think. The question in the chat about whether these actually work. Somebody mentioned that they put in a MUA with data logging, but didn't really get much actionable intelligence back from it. Is this an important piece or useful for building owners to have when it comes to installing these new systems?
You know what? I don't really have a comment on particular technologies other than the fact that when things go wrong, like it can go from like an installation issue to like the wires just like didn't physically connect, which is just like, oh, I guess that happened. To like sometimes it even takes like a couple winters to actually figure out what went wrong. So you could have data and then like trying to figure out a story with that can be really challenging. So I don't know. If anyone has an answer, that would be great. But right now, we're just trying to diagnose problems as they come. But also, like one of the things that I want to do now that we have more complicated systems, like, is to modernize that and come up with a way to manage this big portfolio of more complicated rooftop units.
I might just add that we have seen clients use fault detection, and UBC uses it, probably the best of anyone I know, and they're still working through, like, sorting through all of the faults that don't make sense and developing the correct triggers for alarms and nuisance alarms. And like, there's so much data in fault detection. And so we have seen it work for sure. The clients that are doing it successfully have people dedicated to the fault detection software. Like they're going through, they're removing nuisance alarms, they're tagging things appropriately. There's a lot of work required to make a fault detection system work, is what we've seen in practice. So yes, but it's not like a plug and play and then all of your alarms are correctly configured. Oftentimes, like they're tagged incorrectly or they're configured incorrectly. And so that might have been why you weren't seeing the flags appropriately. I just have one other question on, or one other comment on this heat recovery for RTUs. Brandon mentioned that it's non-standard. For rooftop units, the heat recovery it's not as important because you're directly mixing that return air. So theoretically, if you have, say, CO2 sensing, you could only bring in like 10% of outdoor air, and then the rest could be return air. So you are kind of getting heat recovery from the space. But for makeup air units, you can add on an HRV or an ERV. That definitely is an option we've considered.
Thanks, Steph. I was wondering whether to flag that one because it's interesting, but I didn't know if anybody could talk about it in less than 60 seconds, which you did. And that is going to be our last question because we're at time. Thanks, everyone. I hope that was helpful. We will, to address a couple of questions in there, be providing a recording of this. Just got to get it cleaned up a little bit, but it'll be available through the ZEPEX website. Look forward to seeing you all again at a future session.
Thanks, everyone.